All right. 9.1, new chapter. This is all a chapter about polynomials. So polynomials and factoring, you're going to be doing a lot of that throughout this chapter. The first thing, let's go ahead. We've got a couple of kind of key vocabulary concepts to go over. And this first one is a mononomial, is a number, a variable, or the product of a number and one or more variables with whole number exponents. So the degree, and I'll go over that in just a minute, the degree of a mononomial is the sum of the exponents of the variables in the mononomial. So this is a mononomial, but because it does not have an exponent in it, the degree is 0, because that would be exponent to the degree of 0, which is 1, 10 times 1, you get it. This one, 3x, that is also a mononomial. It is a number multiplied by a variable, and the degree is 1. You can see that. This one, 1/2 ab squared. So now we've got a number, 2 variables, and one of the variables is squared. So then we're going to take this variable right there, 2 plus a to the 1 is 3. So my degree is 3 of this whole mononomial. Right here, negative 1.8 times m to the 5th. My degree is, you guessed it, the 5th. Right there, you can see it. These, when it's a adding or subtracting, then it's no longer a mononomial. It has to be, well, this is kind of like a division, but multiplying or division, which is really multiplying times a fraction. You also cannot have the variable on the bottom of a fraction. So like if this had been 1 over a times b squared, that would not have been a mononomial. So then this, you also can't have the variable in the exponent position. Couldn't have been ab to the c or 1/2 to the a power. And you can't have negative exponents. So the variables must have a whole number, which means a positive whole number. Well, whole numbers are all like 1, 2, 3, 4. Are counting numbers. It's kind of how somebody said it. Okay, a polynomial. So that's a mononomial. You can think of mono means one, kind of Latin words. Poly meaning many. And mono, so mono means one. It's just things multiplied times each other. Poly means is a mononomial or a sum of mononomials, each called a term of the polynomial. The degree of a polynomial is the greatest degree of its terms. So this is a polynomial, 2x cubed plus x squared minus 5x plus 12. So my degree is 3 because that's the greatest, the degree that I have. And the leading coefficient is the first term of the, I don't know how to say it, but it's that 2. And then the constant term is this at the very end, the 12. So, write 15x minus x cubed plus 3 so that the exponents decrease from left to right. So we want, whenever you're writing polynomials, almost always you're going to write it where the highest degree variable is going to go first. So you're going to write negative x cubed plus 15x plus 3. So then we can see that negative 1 is my leading coefficient. My constant term is going to be 3. And my degree of this polynomial is going to be 3. Okay, binomials and trinomials. Polynomial has 2 terms called a binomial, and with 2 terms is a binomial. Think bicycle, 2 wheels, tricycle, 3 wheels, 2, 3. So the number 9 right there is it a polynomial? It is. It's actually a mononomial, but it's also a polynomial. So all three, polynomial, mononomial, binomial, and trinomial. Sorry, let me say this again. Mononomial, binomial, and trinomial are all polynomials. You also can have more than 3, but we're going to start with that. So this is a mononomial with a 0 degree. This one is a polynomial, and it's a trinomial. You can see 1, 2, 3. This one is a binomial. Well, no, because it would be a binomial, except that it's to the nth degree, so it can't be a binomial, so it's nothing. It's not a polynomial. This one has a negative exponent, so that's not either. This one right here, that is a 5th degree binomial. 5th because we've got to the 4th and to the 1, we add those together, and that equals 5. This one is plus 3 and 1, so that's 4. So we actually would write this term first and then that term. And you can see that that's 5 right there. So 5th degree polynomial. Okay, new examples right here. Find the sum 2x cubed minus 5x squared plus x plus 2x squared plus x to the third minus 1. So really we have it all in parentheses, but we don't really need it in parentheses because we're just adding. If it was subtracting, then we would need to take that negative and apply it to all parts of this, but because it's just adding, we could really get rid of these, and then we're just going to add and subtract like terms. So 2x cubed, yeah, 2x cubed plus x cubed, so that would be now 3x cubed. Minus 5x squared plus 2x would be minus 3x squared plus x minus 1. So the way that they do it is kind of writing them one on top of each other like that, so that you can see kind of, so that the like terms go together. And we can see 2x cubed plus x cubed is 3x cubed, minus 5x cubed plus 2x cubed is 3x cubed, plus x minus 1. That's a great way to just kind of keep it all, so you know you don't lose any, and you're going to go ahead and you can see the like terms going together. So similar with this one. Oh, they're now doing the horizontal format. That's kind of how I did it. But 3x cubed plus x minus 6 plus x cubed plus 4x plus 10. So start with the 3x cubed plus 3x squared plus x squared. It's going to be 4x squared plus 5x, because it's 1x plus 4x is 5x. And 10 minus 6 is going to be minus 4. So you can see 4x cubed plus 5x plus 10. So just adding, subtracting your like terms there. Similar here, except now we're subtracting, so we need to make this positive, that negative, and that positive, because that negative is going to go through the whole thing. So 4n squared plus 2n squared. So that's going to be 6n squared. We've only have one 2n, so minus 2n. And then here we can see how they kind of did it vertically like that. 6n squared minus 2n. And then we've got 5 plus 4 is 9. This one similar. 4x squared minus 3x squared is going to just be now x squared. Minus 3x plus x is going to be minus 2x. And plus 5 plus 8 is going to be plus 13. So 2x squared minus 2x plus 13. This last problem is just about baseball attendance. And we have a polynomial to describe the different baseball attendance, and they want us to add them to see what it is at both the National and the American League baseball teams. So add the like terms. It's going to be negative 806t squared plus 8,470t plus 50,300. There you go. That is 9.1.